Hi class. So this is our first notes that we're going to do. If you guys remember last class, we did sum and differences. So today what we're doing is double angle and half angle formulas. So these are the formulas here. Double angle, so you have sine of 2 theta is equal to 2 sine theta cosine theta. Cosine of 2 theta, this one can equal this equation, it can equal this, it can also equal this, and then you have tangent of 2 theta. On your formula sheet, that is located on the back. So in this case, here we have sine of 2 theta, tangent 2 theta, but cosine of 2 theta is equal to 3 different equations, and you actually get to pick which equation to use, and they all give you the same value. But again, here you're using cosine, here you're using sine, here you're using cosine and sine, so depending on the information that the problem actually gives you. All right. You need to copy this down, not just watch the video, because again, you learn by doing. Excuse the awkward shadows, and hopefully over the next videos, I'll have that figured out. Okay, so section 7.4, first problem. If sine theta is equal to 2/3 and theta has its terminal side in quadrant 1, so well, what does that mean, terminal side? That means that it's ending up in quadrant 1. Okay. So here's quadrant 1. Here's your theta. Sine is 2/3. Sine is defined by the opposite over the hypotenuse. So in this case, the opposite is 2. The hypotenuse is 3. Okay, find the exact value of each function. And so we're going to go to our, identities and figure that out. But before we continue, what we want to also do is make sure we have all 3 sides. So figure that out using Pythagorean theorem. Okay, so now I have my triangle complete. I'm going to go to sine 2 theta because my identities I can only use this equation. So that's equal to 2 sine theta cosine theta. And in this case, sine of theta, they gave it to you in your problem, so you didn't have to figure that out. Cosine of theta, I'm going to go back to my triangle. Well, cosine is the same thing as adjacent over hypotenuse. So the adjacent over the hypotenuse is square root of 5 over 3. Last thing you're going to do is just multiply across, clean it up. So 2 times 2, so that's 4 square root of 5. 3 times 3, 9. Looks good. Nothing has to be rationalized. So sine 2 theta equals 4 square root of 5 over 9. Next problem. We're going to do this one twice. So here, cosine of 2 theta, I have 3 choices to pick from. So looking at this, I know in my problem they had given me the sign, so I'm just going to pick this problem here. So cosine of 2 theta is equal to 1 minus 2 sine squared theta. All right, so 1 minus 2. Well, sine of theta I know is 2/3, and square it. So 1 minus 2, 2/3 squared is 4/9. 2 times 4 is 8/9. So 1 minus 8/9, or 9/9 minus 8/9 is 1/9. So cosine 2 theta equals 1/9. ninth. Now suppose I hadn't used that formula and I had picked a different formula. Let's just go ahead and use this one. Okay, well, cosine, same thing, adjacent over hypotenuse. So that's going to be square root of 5 over 3 squared minus the sine. They gave it to me, so that's 2/3 squared. Clean it up. So it's going to go to both of those. Square root of 5 times square root of 5 is just 5. 3 squared is 9. 4/9. Okay, so which problem was easier? Well, this one I only used one value that they gave me. This one I had to calculate that one, but doesn't really matter. You get the same response. All right. Okay, so next problem, I'm going to run out of room because I'm doing my landscape, but you guys just continue on your paper. So next problem is tangent to theta, and I just redo the same triangle because I'm on another paper. So I'm going to go back to my formula sheet, figure out what that formula is. So tangent to theta is equal to okay, so in this one, I just have to figure out what the tangent is. Here's my triangle. So tangent is defined by the opposite over the adjacent. So tangent of theta is the opposite over the adjacent. So that is 2 over square root of 5. Okay, so then I'm just going to go ahead and plug that into my formula. So I have 2 times 2 square root of 5 over 1 minus 2 square root of 5 squared. That's it. Last thing you have to do is just be careful with your math and simplifying, which can be a little bit confusing. So this 2 times 2 is 4 over square root of 5. 1 minus 4 square root of 5 times square root of 5 is 5. So we have to get this to have a common denominator. So this is the same thing as and again, some of you didn't need to do that. You just do it in your head. That's great. Okay, so now we have this, which turns into you multiply by the reciprocal. So this is now 4 over square root of 5 times 5 over 1. So your answer is 20 square root of 5. Done. I would actually mark that wrong on a test because you're not allowed to have square roots in the denominator. That's bad math. So you would need to rationalize. To rationalize, multiply top and bottom by square root of 5 over square root of 5. Again, you're just square root of 5 over square root of 5 is just once. You're not changing the value. You're just changing the way it looks. So final answer is 20. And of course, 5 goes into 5 once, 5 goes into 24 times. So final answer, the tangent of 2 theta after all that work is 4 square root of 5. This is an exact answer. Otherwise, you could have gotten a decimal answer. Okay, so this is still part of problem 1. This one is cosine of 4 theta. A little bit more confusing because if I go to my identities, I don't have a 4 theta. It's just the double angle formula. So how can I rewrite this? Okay, well, this is actually the same as cosine 2 times 2 theta. So how does that help me? All right, so if I look at this, I do have a formula for cosine of 2 theta. So then I can say cosine of 2 theta is equal to cosine squared 2 theta minus sine squared 2 theta. I have to know what the cosine of 2 theta is. Well, if you look back to the problems we've done, we actually figured out that the sine of 2 theta is this, and the cosine of 2 theta is this. So we're going to use cosine 2 theta, 1/9 squared minus the sine of 2 theta and again, that's because I knew sine of 2 theta, cosine of 2 theta. And here, I'm plugging it in. So to figure out 4 theta, do your math. So this is just 1/81. This one turns out to be 4 square root of 5/9 times 4 square root of 5/9. So this is just going to give you 16, 4 times 4, 5 times 5/81. So that's going to be 6 times 5, whatever that is. Okay, so 181 minus 80/81 is negative 79. Okay. So again, this part was just knowing that you had already found that in the first part. So cosine 2 theta, sine 2 theta, and then plugging in those values which you had already calculated. All right, so here we go. So this is now problem number 2, the half angle identity. So if you go to your formula sheet, the half angle identities are right here. So sine, cosine, and tangent. Now, if you look at these, you actually have a plus minus. It doesn't mean that you're going to get 2 answers. It means you actually have to pick whether the answer is positive or whether the answer is negative. The way you figure that out is based on which quadrant it's in. So for example, here, if you guys look at your unit circle, you can see that all trigonometric functions are positive. So cosine, all positive. Sine is all positive. Tangent is positive. On this side, you could see that cosine is going to be negative and sine is positive, which would make tangent negative. Here you would see that both cosine and sine are both negative, which would make tangent positive. And here your cosine is positive and tangent is, or cosine is positive, sine is negative, tangent would also be negative. A short way to remember that is all students take calculus. So that means that all trigonometric functions are positive here. Only the sine function is positive here. Only the tangent function is positive here. And the cosine function is positive here. Also, if you were to do the inverse, like the cosecant, cotangent, and secant, those would also be positive. Okay, and that's a way to memorize that or remember that. So we're going to use the half angle identity to find the sine of 7 pi over 12. Well, where is 7 pi over 12? So you can figure it out on the unit circle, the way you count, or what might be easier is just to convert it to degrees. So if you convert 7 pi over 12 multiplied by 180 over pi, figure out what that is. So you get 105 degrees. So if you look at your unit circle, 105 degrees would be in quadrant 2. So 105 degrees would be in quadrant 2. And we're finding the sine. So sine would be positive. Okay, so this is the same thing as sine 105 degrees. And it's in quadrant 2. Which makes your final answer positive. So then I'm going to go down to my formulas and just plug all this information in. So I have to find sine of 105, but there isn't 105 on my unit circle. So what angle, if I'm looking for 105, what angle can I take half of it to give me 105? Very good, 210. So we're going to use the angle 210. So we're going to say, using this formula, we know it's going to be positive because of this, so we don't have to do the negative. So that's going to equal 1 minus the cosine of 210 over 2. Okay. So all I did there was take 105. 105 is going to be half of what angle on the unit circle would give you 105. So it has to be 210. So plugged in 210 and then just plugged in my values there. And again, because I know what the cosine of 210 is from the unit circle. So from here, just plug in your values. So this is the square root 1 minus. Well, the cosine of 210 degrees is going to be negative square root of 3 over 2, right there, cosine. All right, so now we have to simplify this. So first thing we have to do is, that looks ugly, so that turns into just that piece. It's going to be 2 over 2 plus, it has a common denominator, so that's good. And these problems do have like square roots within square roots, so they do look a little bit ugly. So this is going to be that's this right there, all divided by 2. Okay, you cannot leave your answer like this. You have to combine them and make it look a lot nicer. So in order to do that, you're going to go ahead and if this is division, you're going to multiply by the reciprocal. So this turns into times the reciprocal of this, 1/2. So it turns in all over 4. You cannot reduce those because of the plus sign, and looks good. The last thing is we did have the big square root and it was positive. So this becomes our final answer. All right, we're almost done. Last problem, here we go. Next problem is the cosine of 67.5. Again, if we go here, of course 67.5 is not on the unit circle, so we're trying to double an angle, or in this case we're going to take half of an angle. So half of what angle would give you 67.5? Again, just think about it. If you're not sure, same thing, 67.5 times 2, so it's 135. All right, so we're going to go to 135. Well, if we look at the unit circle, we're looking for cosine. So cosine of 135 is here. So we're going to use these values. But because we're finding the cosine of 67.5 degrees, 67.5 degrees would lie here. Because 67.5 degrees lies here, that means that your all the signs are positive in this section, so your answer is going to be positive. So And then we're going to go based off of the 135. So it is in quadrant 1, which makes it positive. And this is the same thing as cosine 135 degrees divided by 2. I'm going to use my formula here. My answer is positive, so I don't need to worry about the negative. So that's the square root of cosine of 1 plus cosine of 135. So going to go here. Cosine is negative square root of 2 over 2. Negative all over 2. Clean this up, so you have to get a common denominator. Okay, again, we can't do that, so we're going to go ahead and multiply by the reciprocal. So this is going to be okay. Now remember, I have all of this stuff under the square root. Looks pretty good. Okay, last part, because that's a 4, you can actually simplify it, so you can break it apart into the square root of 2 minus square root of 2 over the square root of 4. So that turns into all over 2, and our final answer was positive. So again, this is your exact answer. If you just plug this into your calculator, you would get an approximate decimal answer. Again, if you plug this value into your calculator, you would get the same. All right, this was a long lesson. That's it. All right, thank you.